Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at the law of sines, and particularly in the context of angle, side, which will make more sense in a moment. So let's go ahead and get started. So I'm sure, as you know, if we ever want to find out the lengths of a right triangle, we can always use the Pythagorean Theorem. So I have something like this. Just assume that this is drawn to scale, of course. And of course, right here I have my right angle, and let's say I have a 3 and a 4. Well, it's not that hard. So I do 3 squared plus 4 squared, and of course I gotta give this a value here, so C will equal C squared, and then you can calculate the rest on your own. However, the Pythagorean theorem only works when you have right triangles, unless of course you want to try to play with the triangle in some sort of way to make it a right triangle. So let me see if I can make it clear what I just said. Let's say I have something like this. And so in this situation, what I could do is I could do something where, well, this looks like it might be a right angle, or I could just draw something like that and then make two triangles and add them together. In other words, I can always try to find ways to find the altitude or the height of the triangle and then use that to try to find the lengths of unknown sides or try to find the area or whatever it is that I want to know about the triangle. However, there is a way to where you can find the lengths of sides and whatever else and once you know the length of the different sides, you can do other calculations. You can also find ways to find the angles, the different angles of the triangle when it is not a right triangle. And generally, almost always, when a triangle is not a right triangle, we say that it is oblique, an oblique triangle. Again, the details behind this is beyond the purpose of this video. But if it is not a right triangle, it is called an oblique triangle, often, almost always in mathematics. Now, let me see if I can try to clarify even more what we're talking about. So imagine that we have these different types of triangles, and when we're dealing with oblique triangles, like I was just mentioning, they can be used to calculate whatever it is you want to know. Now, there are three ways that you could, three types of information that you need to know in order to deal with oblique triangles. Now, having said that, this is what we need to know. We need to know an angle, a side and the angle, something like that. We can know two sides in the angle, or we can know two angles and a side. That's kind of how it works out. Now, let me see if I can draw you a picture of what I just wrote here. So if I know angle, side, angle, it's going to look something like this. Of course, obviously this is not a right triangle. This is an oblique triangle again. And so I might know this side. I might know this, this angle, and I might know this side. And so with these three pieces of information, I can calculate, the length of the other sides, or I can even calculate this unknown angle right here. So I could calculate, this side, or I can even calculate this angle. Now, over here, I think you're starting to pick up the pattern. If we had to draw this again, so I know one angle, and then I might know two sides here. So again, I can use this information, this one angle and these two sides, and I can calculate, I can calculate this side, I can calculate the angle here, whatever. Whatever. As long as I have a combination of knowing at least two angles or two sides, I'm okay. Knowing two angles or two sides and one angle and one side, either one, then I'll be okay. And just to finish it off here, angle, side, I'm sure you have an idea of what this looks like. And so I know this angle, I also know this angle, and then I know one of the sides. And I can take this information right here, and I can figure out the side here, I can figure out this side, or I can even figure out this angle right here. And that's how it works. Now, the question you're probably asking now is, okay, Darren, what do I do? What is the process for using this information to find out the sides or the angles of an oblique triangle? Well, it is called the law of sines. Oh, excuse me. The law of sines. Yes. Yeah, we want the E here. Okay, so the law of sines is basically as follows. Let's say I have a triangle. I always have a triangle. And it's something kind of like this. And so I have a side, I have a psi alpha here, and I have a side beta here, and I have a side gamma here, and then after that I have my angle A. Angle A is going to be over here, angle B is going to be over here, angle C is going to be over here, like so. Now here's how it works to make this as simple as possible. The sine of alpha over A equals the sine of beta over B equals the sine of gamma over C. They all equal each other. Now the mystery over why they all equal each other is something you can discover on your own time in terms of how it works. But with this information here, we can use this to try to solve for whatever information we have in our triangle problem as an example. And so what we're going to do now here, oh, but there's one more thing I got to mention. The reciprocal of this also applies. So again, just to draw it down here, if I put the capital A, it'll be sine over alpha equals capital B sine over beta equals capital C sine over gamma. This also applies as well. I forgot to mention that. Now, with this information, we can use this to solve a triangle. But what we're going to do right now is we're going to solve a triangle that has an angle side triangle. And I'm going to show you how this works in actual context. So let's go ahead and get started here. So let me see if I can try to draw our funny looking triangle here. It's kind of funny looking like this. So you can see, hopefully that's definitely not a right triangle. This is definitely an oblique. Not drawn to scale, obviously. And so we have our angle here, our angle of alpha. And then we're going to have our beta right here. This is going to be the long slash. And this is going to be our gamma right here. Gamma is the Greek letter. All right. And then we're going to have our sides. And so this side is going to be 22. This is our capital B guy here. And then we have a side C. We don't know this side. And we have our side A. We don't know the length of that side. And then also we got to put in our degrees here. So this guy right here is going to be 98 degrees. And then over here, he's going to be 43 degrees. All right, now, this is not that big of a deal. There are several things we do first. First, we want to figure out what is the angle of beta. Because since we know, if you know two angles, you can find a third one. Because we know that a triangle adds up to 180 degrees. So this is just a matter of simple math. We take 180 minus 98 minus 43. And that, if you look it up on your calculator, is going to be 39. So part of the mystery is already solved. We know that beta is 39 degrees. This is why, this is relatively easy considering the context. Now, what we need to do is we need to remember our little law of sines here. We have sine of alpha over A equals sine of beta over B equals sine of gamma over C. Now, we know one side. And so we can pick any other two sides to try to finish it. That's essentially what we can do here. So this is what we're going to do. We're going to take sine of 98. So sine of 98. Let me see if I can make this nice and clear here. Sine of 98 degrees. Put that in parentheses. Over A. And now what side do we know? Well, we know the side of this guy right here. We know this on beta, so we're going to use this one because we know the B side. So this is going to equal, B over here is going to be 22 this time, and it's going to be sine of 39 degrees, like that. That's what we do. Now, the first thing we're going to do is multiply both sides by A, and so now we end up with sine 98 degrees equals sine of 39 degrees over 22, and all this is going to be multiplied by A, like that. So that's what's happening there. Now, this is where it gets tricky. see if you can follow along here. I'm going to do this on the next slide. So we got sine of 98 degrees equals, let's see here, sine of 39 degrees over 22, and this is multiplied by a. Now, we need to try to isolate the a. In order to do that, we're going to multiply both sides by the reciprocal of sine of 39 degrees over 22. That's what we're going to do. This is so important. Got to make sure it's clear. So I'm going to multiply this side by 22 over sine 39 degrees like that. Multiply this side over here. Get this guy in it by himself of 22. Sorry, not a lot of space here. Sine 39 degrees like so. These cancel out on this side, as you can see. And so we end up with the following. I hope you're following me here. We end up with sine, 22 degrees times sine of 39 multiplied by sine of 98 degrees equals a. Now it's just a matter of putting it in the calculator to finish off the experience here. So I go to my calculator, and I already put it in there for you, but you can see right here I put sine of 98 times 22 divided by sine of 39, and our final answer is 34.68. So in other words, a equals 34.68. Now if I go back to my calendar, if I go back to my my problem here, I know that the angle A equals 34.68. And then we can repeat this process if we desired to find out what angle C is. And so, we could if we wanted to, but I think you get the idea of how this is addressed in terms of what you need to do. And so now what we can do is we can take this information here and we can continue the process. Let's see, I guess we can go ahead and do that. Why not? So this is 34.68. And then we can move on from there. So let's see here. So now we got sine of, let's see here, beta, sine of 98 degrees over 34.68 equals, and now we want to find this the angle C. So sine of 43 degrees over, we don't know what C is. All right, now again, we go through the same process. We multiply both sides by C, and so we get C over here, sine of 98 degrees over 34.68 equals sine of 43 degrees. We multiply by the reciprocal of this guy right here. So what we end up having is C equals sine of 43 degrees multiplied by 34.68 over sine of 98 degrees, like so. And so we put this into the calculator. Let's see what we got here. So we got sine of 43 degrees multiplied by 34.68, and then sine of 98 degrees. And then we get a length of 23. That makes sense. So C equals 23.88. And essentially we're done. So if I had to go back here, I would say this is 23.88. And those are the three sides of this triangle. And so you can see how the law of sines can be used to calculate the sides of angles, or even to calculate the sides of triangles, and or to calculate the angle of different triangles. But we'll learn about that later. So let me see if I can wrap up and talk about what we did and conclude the video. So in this video, we talked about, trying to find the lengths of sides or to calculate the angles of triangles that are not right triangles. And generally, any triangle that is not a right triangle is called an oblique triangle. That's what's happening here. And so with that knowledge, you have to be familiar with several pieces of information in order to use what we call the law of sines. You have to have two angles in one side, or one side and two angles, or one angle and two sides, some sort of a combination like that. And you can use that information to find out the other pieces of the puzzle. And so then we did our actual example right here after we talked about the law of sines. This is our example right here. And we went through the process, and this is an example of a angle side situation. In other words, I know two angles and I know one side. And so once you find the second side, you can find the third side, etc. You can just kind of build on it, and that's what happens. And we went through the multiplication process. It's just a lot of basic algebra type ideas, nothing too complicated there, and we were able to finish it. So I hope this video was useful for you and you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.